Okay, very good morning, friends. We are discussing about today photo detectors. Okay, photo detectors. The photo detector senses the luminescent power falling and converts the variation of the optical power into a corresponding varying electric current. The photo detector must meet very high performance requirements. Those are with high response or sensitivity in the emission wavelength. Okay. In OFC system, there must be a receiving device which interprets the information contained in the optical signal. And also the first element of this receiver is a photodetector. Different types of photodetectors are in existence. They are photomultipliers, pyroelectric detectors, and also photodiodes. Photomultiplier structure is like that. Photomultipliers Photomultipliers consist of a photocathode and an electrode multiplier packaged in a vacuum tube that are capable of providing very high gain and very low noise. Photomultipliers. Next, pyroelectric photodetectors. So, what are these pyroelectric photodetectors? They involved in the conversion of photons to heat. They give rise to variation in the dielectric constant, which is usually measured as a capacitance change. Photodiode. Photodiode is used almost for all fiber optic systems because of its small size, suitable material, high sensitivity, and fast response time. These two types of photodiodes used are pin photodetector, avalanche photodiode. The most commonly used photodetectors is the photodiode. The device structure consists of PN junctions separated by a very lightly endoped intrinsic region. Okay. In normal operation, a sufficiently large reverse biased voltage is applied across the device so that the intrinsic region is fully depleted of carriers. Next, so the intrinsic N carrier and P carrier concentration is negligible small and it is compared with impurity concentration. Pin photodetector. When an incident photon has energy greater than or equal to the bandgap energy, the photon can give up its energy and exit an electron from valency band to the conduction band. Okay. Pin photodetector. This process generates free electron hole pairs which are known as photocarriers or photon generated charge carriers. The carriers are generated in depletion region where most of incident light is observed. Okay. Photo generated electron or photo generated hole. Photodetector. So, what is pin photodetector? This gives a current flow in an external circuit with electron flow for every carrier pair generated. This current flow is known as photocurrent. As the charge carriers flow through the material, some electron hole recombine and hence disappear. The charge carrier travels at distance ln or lp for electrons and holes respectively. This distance is known as diffusion length. The time it takes for an electron or hole to recombination is known as carrier lifetime, and it is represented by Tn or Tp respectively. These lifetimes and diffusion lengths are related by ln is equal to Tn and Tn square root of Dn and Tn. Lp is equal to square root of dp into Tp, where Dn and dp are electrons and holes of diffusion coefficients. Pin photodetector. The optical radiation is whenever the optical radiation is observed as P of x is equal to P in of experimental exponential of alpha s into x, where alpha x is absorption coefficient at a wavelength lambda, where Pin is equal to the incident optical power level. P of x is equal to optical power observed in a distance x. If the depletion region has a width w, then the total power observed in the distance w is P of w is equal to P in of exponential value of minus alpha s into w. Pin photodetector. So what is pin photodetector?